Hello Year 5. Today we're going to be looking at prime factors. I wonder if you can look at the picture here on the screen and see if you can work out what you think a prime factor might be. Here is a quick starter activity to recap what we've done before. I would like you to find the factors of these three numbers, please. Remember to work systematically. Find the factor pairs first and then put the factors in order. Pause the video while you answer the question. How did you get on? If you were incorrect, can you work out where your mistake was? Pause the video while you mark. We learnt the definition for product in our multiplication lesson. Product means the answer when two numbers are multiplied together. This is important for today's lesson. Prime factors are something on the curriculum that I always find a little bit random because you don't tend to use them in real life and they don't really come up in assessment either. But it really interests me that whole numbers can be written as a list of prime numbers multiplied together. And this is what we call writing a number as a product of prime factors. So for example, 12 can be written as 2 times 2 times 3. So 2 times 2 is 4, times that by 3 is 12. 45 can be written if you multiply the prime numbers 3 times 3 times 5. 3 times 3 is 9, times 5 is 45, and so on. The definition for a prime factor is really easy. It's a factor that's a prime number. So today you are going to find prime factors of numbers. Once you've finished those tasks, there are some extend challenges at the end of the video, which are based around factors, multiples and primes, so some work that we've done over the last couple of weeks. They are in your home learning pack. You may have found them already. Here are the steps for finding prime factors. Basically, you break the number down by its factors to find prime numbers. If I'm looking at the number 16, I need to think of two numbers that multiply together to make 16. So I've chosen 2 and 8. Can you have a little think about why I wouldn't choose 1 and 16? Tell somebody around you why I wouldn't choose 1 and 16. Hopefully some of you have said that it's because 1 isn't a prime number, so there's no point in looking at that. 2 and 8, I know that 2 is a prime number, so I circle the 2, and I can leave that alone for now. And I move to the 8. Now 8, I need to break that down. I know that 2 times 4 is 8. Again, 2, circle it as a prime number, leave that alone, move on to the 4. And then 4 can be broken down to 2 times 2. You could have also started with 4 by 4. Up at the top, 16, a factor of 16 is 4, so you could have done 4 times 4 and broken it down that way. There are multiple ways for you to do this today. But eventually you should get to the answer where you've got 4 2's circled. And that means that 16 is equal to 2 times 2 times 2 times 2. And we know that because 2 times 2 is 4, times that by 2 is 8, times that by 2 is 16. It does seem confusing with all the numbers everywhere, but the steps hopefully are quite simple. Here's a slightly simpler version. So I start with the number 20 and I think of two numbers that multiply together to make 20, two factors, so I've gone with 4 and 5. I know that 5 is a prime number, so I circle 5 and I leave it alone. I then look at the 4 and I think, what are factors of 4? What multiplies together to make 4? 2 times 2. 2 is a prime number, so I circle both of them, and I don't have anywhere else to go. So I know that 20 is a product of 2 times 2 times 5. I know that's correct. 2 times 2 is 4, times that by 5 is 20. I could have approached this another way, and it's important to realise that today you might have different options, but go with whichever one you are happy with. I could have done 2 times 10, and I would have circled the 2 straight away, moved on to the 10, and worked out that 2 times 5 equals 10, and I know that in the end I get the same answer. When I'm writing out my number statement at the end, make sure you put the numbers in order. So I wouldn't, for example, here write 5 times 2 times 2. Start with the smallest and work up to the biggest. 2 times 2 times 5. I'm going to talk through one more example before you have a go. So I'm going to use the number 24, and I've chosen 4 and 6. Now you know you could have chosen 2 and 12, 3 and 8, but I will show you this example. So neither of 4 or 6 is a prime number, so I have to break those down further. So 4, I break it down to 2 times 2. Both of those are prime numbers, so I circle them. Then I go over to my 6, 2 times 3. They're both prime numbers, so I circle them. So again, 2 times 2 times 2 times 3. It's now your turn to have a go at finding the prime factors of 18. Make sure you write them out neatly in your book, and remember to circle the prime numbers once you've found them so you know you don't have to break them down any further. Pause the video. So hopefully you've got one of these options. You could have started with 2 times 9 is 18. 2 is a prime number. So I look to the 9, and 3 times 3 is 9. 3 is a prime number, so I circle them. Or some of you might have started with 3 times 6 and identified 3 as the prime number, and then broken down 6 into 2 times 3. Note that when I've written out my number statement at the end, I put the numbers in order from smallest to largest. So 18 is equal to 2 times 3 times 3. I hope you got that correct. It's now your turn to have a go at finding the prime factors of 28 and then of 90. 90 is a bit of a challenge. Pause the video. You may have done a different approach, but hopefully you got to the answer 28 equals 2 times 2 times 7. It's 28. Factors of 28 are 2 and 14. 2 is a prime number. 14 isn't a prime number, so I need to find factors. 2 times 7. 2 and 7 are both prime numbers. You will need good times tables knowledge to answer the 90 question. So you may have begun with 2 times 45 is 90, so you can circle the 2. You should know that 3 times 15 is 45, circle the 3. And then 15, 3 times 5 is 15, circle the 3, circle the 5. So 90 is a product of 2 times 3 times 3 times 5. I can check that by thinking in my head. 2 times 3 is 6, times that by 3 is 18, times that by 5 is 90. Here is the first of your challenges today, which can be found in your home learning pack, so you can write on the sheet or you can just use the screen here and write in your book. You have got to crack the code. So let's just look at the first clue together. So this number is a multiple of 7 and 2, and it's a factor of 28. If it's a multiple of 7 and 2, I just have to multiply 7 times 2, don't I? Which is 14. And let me just check, is 14 a factor of 28? Yes, it is, because 2 times 14 is 28. Where it says notes or number, you might have wanted to jot some of that down, or you could jot it down in your book on a piece of paper. But the number I'm looking for is 14, and that letter is N. So in number, I would put 14, and in letter, I would put N. That's my first clue. Now, it does talk about square numbers and cube numbers, which we did do together before Christmas. If you're not sure, have a look on BBC Bitesize for what a square number is and what a cube number is, and it should show you a video. But most of you should know, and you should be able to apply your maths knowledge to working out this challenge. So pause the video and have a go. Your final challenge for today. I absolutely love this investigation about abundant numbers. So an abundant number is a number that's less than the sum, the total, of its factors. So let me go through this example with you. If you think about the factors of 48, you find 1 and 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8. Now you leave out the original number itself, so you leave out 48, but you add together all of its other factors. So 1, add 2, add 3, add 4, add 6, add 8, add 12, add 16, add 24 is 76. 76 is higher than 48. So 48 is an abundant number because it is less than the sum of its factors. So I want you to have a go at finding some more abundant numbers. Think about working systematically. Start with smaller numbers and work your way up. Do you notice any patterns? You might just want to go off and do this by yourself. If you're struggling to think of numbers, I've just selected 5 numbers, 12, 19, 25, 28, 42, and have a go with those numbers and see if any of them are abundant and if you notice any patterns. I think you will have to do quite a few before you work out abundant numbers or numbers which are not abundant, and you can message me your findings. I'm not going to post the answers for the challenges just yet because especially this one, the investigation, I think will take you quite a while. But please do either upload to Padlet or email your teacher with the responses. I'm particularly interested for my class in the investigation, the abundant numbers, to see how you've done. So I hope you enjoy this. It is a little bit tricky. I am challenging you today, but have a go and then let me know how you get on.